Good morning, my dear students. Today is the first class. I hope you are safe. Before I start the syllabus, I want to recall few concepts related to the topic, that is computational linear algebra. The journey of the computational linear algebra starts from the word the binary operation. You are all familiar with this word, the binary operation. I am here, you are there. The internet is connecting between you and me. That means the internet is a binary operation. Binary operation means connecting two things or connecting two matters or connecting two elements. Okay. Now, using binary operation, we defined the definition of group. Using the definition of binary operations, that is addition and multiplication, we defined rings, and we studied the number of theorems related to rings. Now I move to the vector algebra, that is the linear algebra. To define a vector space, we need to know two concepts: internal composition and external composition. Before we study internal composition and external composition, we must know what is the meaning of Cartesian product. To define a Cartesian product, we need two sets, and we denote it by the notation A cross B. A cross B means the Cartesian product of two sets A and B. Similarly, to define an internal composition, we need a mapping, the transformation or the correspondence from the Cartesian product of vector space to vector space. That means V cross V to V is said to be internal composition. External composition means Cartesian product of vectors and scalars. That means V cross F to V is said to be external composition. That means to understand the definition of vector space, we must have the internal composition. Internal composition means V cross V to V. External composition means V cross F to V. Okay. Now, the set containing vectors with the two binary operations, addition and multiplication, is said to be a vector space if it satisfies some laws. Under addition, that means a non-empty set containing vectors with respect to the binary operation addition is an abelian group. Abelian group means closure law under addition, associative law under addition, identity law under addition, and the additive inverse under addition, and finally the commutative law under addition must holds good. Then only we call it as an abelian group. Abelian group means all the laws of groups, but here we have to use only vectors, not scalars. Okay, let me recall. The set containing vectors with respect to the binary operation addition is an abelian group. That means the closure law, associative law, identity law, inverse law and commutative law must holds good under what? Under the binary operation addition. And the next one is what? Distributive law. Don't use the word distributive law because we are using vectors as well as scalars. Simply I'll say alpha, if alpha is a vector, C1 and C2 are the scalars. Alpha is a vector, C1 and C2 are the scalars. Alpha dot of C1 plus C2 can be written as C alpha C1 or alpha, C1 alpha plus C2 alpha. Here we see one vector and two scalars. Now I'll take two vectors and one scalar. C of alpha plus beta. C dot of alpha plus beta. C is scalar. Alpha and beta are the vectors. Here we write it as C alpha plus C beta. Okay. The next one is the last one. One is a scalar. Alpha is a vector. 1 dot alpha, that means scalar multiplication of a vector. 1 dot alpha is same as writing alpha dot 1 and it is equal to what? Alpha only. If it satisfies all these laws, we say that V be a vector space over a field F. Now the question arises in our mind. Field means what here? Field may be set of integers. Field may be set of rational numbers. Field may be set of real numbers. Field may be set of complex numbers. That means F may be set of integers. F may be set of real numbers. F may be set of rational numbers. F may be set of what? Complex numbers. Why this word is there? I mean, vector space defined over a field F. Defined over a field F means what? You see, I want to play cricket. Where should I go? I have to go to ground. That means we can play cricket only in ground, not in the hall or in the room. I want to play a drum. That means whether I have to go to playground or in the theatre itself. You say that certainly theatre, sir. That means with respect to what? You see, I want to see movie. ನಾನು ಮೂವಿ ನೋಡ್ಬೇಕಂತ ಇಷ್ಟ ಆಗಿದೆ. ನಾನು ಎಲ್ಲಿಗೆ ಹೋಗ್ಬೇಕು? ನಾನು ಪ್ಲೇ ಗ್ರೌಂಡಿಗೆ ಹೋಗ್ಬೇಕಾ, ಥಿಯೇಟ್ರಿಗೆ ಹೋಗ್ಬೇಕಾ? ಥಿಯೇಟ್ರಿಗೆ ಹೋದ್ರೆ ಮಾತ್ರ ಐ ಕ್ಯಾನ್ ಸಿ ದ ಮೂವಿ. ದಟ್ ಮೀನ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವಾಟ್? ಕ್ರಿಕೆಟ್ ಅನ್ನ ಗ್ರೌಂಡ್ ಅಲ್ಲೇ ಆಡ್ಬೇಕು, ಮೂವಿಯನ್ನ ಥಿಯೇಟರ್ ಅಲ್ಲೇ ನೋಡ್ಬೇಕು. ಗಾಟ್ ಇಟ್? ಸರ್ ಐ ವಾಂಟ್ ಟು ಕುಕ್ ಸಮಥಿಂಗ್. ಹಾಗಾದ್ರೆ ನಾನು ಎಲ್ಲಿಗೆ ಹೋಗ್ಬೇಕು? ನಾನು ಲಿವಿಂಗ್ ರೂಮಿಗೆ ಹೋಗ್ಬೇಕಾ ಅಥವಾ ಕಿಚನ್ಗೆ ಹೋಗ್ಬೇಕಾ? ಕಿಚನ್ಗೆ ಹೋಗ್ಬೇಕು. ಓಕೆ, ಸೊ ದಟ್ ಮೀನ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅನ್ನೋದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ನಾನು ಅಡಿಗೆ ಮಾಡ್ಬೇಕಾದ್ರೆ ಕಿಚನ್ಗೆ ಹೋಗ್ಬೇಕು, ಕ್ರಿಕೆಟ್ ಆಡ್ಬೇಕಾದ್ರೆ ಗ್ರೌಂಡಿಗೆ ಹೋಗ್ಬೇಕು. ಓಕೆ, ಅದೇ ರೀತಿಯಾಗಿ ನಾನು ಮೂವಿ ನೋಡ್ಬೇಕಂದ್ರೆ ಅಫ್ಕೋರ್ಸ್ ನೀವು ಹೇಳ್ಬೋದು ಮನೆಯಲ್ಲೂ ನೋಡ್ಬೋದು ಅಂತ. ದಟ್ ಇಸ್ ಸಪ್ರೇಟ್ ಡಿಬೇಟ್. ಓಕೆ, ವಿ ಗೋ ಟು ದ ಥಿಯೇಟರ್. ಓಕೆ, ಐ ಮೀನ್ ದ ಸಿನಿಮಾ ಹಾಲ್. ದಟ್ ಮೀನ್ಸ್ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಓವರ್ ಎ ಫೀಲ್ಡ್ ಮೀನ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ವಾಟ್ ಅಂದ್ರೆ ವೆಕ್ಟರ್ ಸ್ಪೇಸು ಓವರ್ ಇಂಟೀಜರ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಾ, ವೆಕ್ಟರ್ ಸ್ಪೇಸು ರಾಷನಲ್ ನಂಬರ್ಸ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಾ, ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಓವರ್ ವಾಟ್ real numbers are complex number. That is most important. Sometimes it holds good, sometimes it may not holds good. This we have studied in BSc, I mean in UG. Now here in this semester you have to study the advanced form of the linear algebra. ಈಗ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಡೆಫಿನಿಷನ್ ಗೊತ್ತಾಯ್ತು. ಇವಾಗ ಏನು ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬರ್ತಕ್ಕಂಥದ್ದು ಸಬ್ ಸ್ಪೇಸ್. ವಾಟ್ ಈಸ್ ಅ ಸಬ್ ಸ್ಪೇಸ್? ಸಬ್ ಸ್ಪೇಸ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ once again we need a set containing vectors and it is subset of V, andre S must be subset of V. Under addition the closure law must hold good. Okay, and under multiplication, associative law must holds good. That means it must satisfy all the laws of what? Vector space. Then we call it as a subspace. In short, subspace properties ಯಾವುದು? ಯಾವಾಗಲೂ ತಿಳ್ಕೊಳ್ಳಿ, ಡೆಫಿನೇಷನ್ ಇಂದ ಪ್ರಾಪರ್ಟಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಪ್ರಾಪರ್ಟೀಸ್ ಇಂದ ಥಿಯರಮ್ಸ್ ಪ್ರೂವ್ ಮಾಡಬಹುದು. Theorems, with the help of the theorems, we can prove the corollary. Using the definition, property, theorem, and corollary, some other things we can prove the lemmas also. Okay. Now, linear combination. Linear combination andre ಏನು? Linear combination andre we have a set of vectors. Using set of vectors, we can form a linear combination. For example, we have n number of vectors. Alpha S is a set containing n number of vectors. Alpha 1, alpha 2, alpha 3, and so on alpha n. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಸ್ಕೇಲಾರ್ಸ್ ಬೇಕು? We need n scalars to form a linear combination. ಹಾಗಾದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? I have to multiply each vector by a scalar and summing. That means C1 alpha 1, C2 alpha 2, C3 alpha 3, and Cn alpha n. Summing means C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 and so on Cn alpha n. So this is said to be what? Linear combination. Linear combination ಗೊತ್ತಾಯ್ತು, ಸಂತೋಷ. ಹಾಗಾದ್ರೆ ಏನು ಮುಂದೆ? Linear combination, with the help of linear combination, we can have the definitions of linearly independent, linearly dependent, basis, and so on. Linearly independent andre ಏನು? Linearly independent and ಹೇಳ್ಬೇಕಾದ್ರೆ, to say the vectors are linearly independent, all the scalar values must take zeros. Remember, to say vectors are linearly independent, all the scalar values must take 0. That means C1, C2, C3, Cn must take what? 0. Out of n scalars, ಒಂದು ವೇಳೆ at least one scalar is not equal to 0 ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಆ ಸಂದರ್ಭದಲ್ಲಿ at this time we say that the vectors are linearly dependent. Dependent means if at least one scalar value is not equal to 0, then the vectors are said to be linearly what? Dependent. Okay, we know the definition of linearly dependent. We know the definition of what? Linearly independent. Okay, now I'll move to the next definition, that is basis of a vector space. Basis ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ the vectors must be linearly independent. Remember, the second condition, L of S equal to V. Now the question arises, what is the meaning of L of S is equal to V? ಅಂದ್ರೆ ಪ್ರತಿ ಒಂದು vector can be, every vector can be expressed as linear combination of vectors. For example, if beta is a vector, that means if beta belongs to V, then beta can be expressed as linear combination of vectors of S. Let me repeat. L of S is equal to V means if beta belongs to V, then beta can be expressed as linear combination of vectors of S. What is S? S is a set containing n number of elements. Say alpha 1, alpha 2, up to what? Alpha n. ಹೇಗೆ ಬರಿಬಹುದು ಇದನ್ನ? This can be written as beta equal to C1 alpha 1 plus C2 alpha 2 and so on Cn alpha n. Okay, now we got the definition of basis of a vector space. Basis in the year find out ಮಾಡಬಹುದು. Dimension. What is the meaning of dimension? Dimension means the number of elements present in a basis of a vector space. ಅಂದ್ರೆ ಬೇಸ್ ಅಲ್ಲಿರ್ತಕ್ಕಂಥ elements ಏನಿದೆಯಲ್ಲ, number of elements, so that will be the dimension of what? The vector space. Okay, now we have two important theorems related to linearly independent and dependent. ಒಂದು ವೇಳೆ if the vectors are linearly dependent, listen to my words with full attention. If the vectors are linearly dependent, there exists a vector alpha k which can be expressed as a linear combination of preceding ones. That means alpha k equal to C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 so on up to what? Ck minus 1 alpha k minus 1. ಇದು ಯಾವಾಗ ಸಾಧ್ಯ? This is possible only when the vectors are linearly dependent. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ವೆಕ್ಟರ್ಸ್ ಇರಬೇಕು? To prove this theorem, I need minimum 2 vectors and maximum n vectors. That means k lies between 2 and n. This we have studied in UG. Okay. Now, if the vectors are linearly independent, ಒಂದು ವೇಳೆ vectors linearly independent ಆಗಿದ್ರೆ ಏನಾಗುತ್ತೆ? We have one important result that we had studied in UG. n greater than or equal to r. n greater than or equal to r. n ಎಲ್ಲಿಂದ ಬಂದಿದೆ? n means the number of vectors present in that set or the number of elements present in that set, and r is also same. That means number of elements present in that. ಅಂದ್ರೆ ಒಂದು ಸೆಟ್ ಅಲ್ಲಿ n number of vectors ಇದೆ, ಅದು ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಇದೆಯೋ ಡಿಪೆಂಡೆಂಟ್ ಇದೆಯೋ ಅದು ಬೇಕಿಲ್ಲ. ಇನ್ನೊಂದು ಸೆಟ್ ಅಲ್ಲಿ we have r number of elements, those vectors are linearly independent. ಅಂದ್ರೆ r vectors linearly independent ಆಗಿದೆ, n vectors simply they are vectors, that's all. They may be linearly independent or may not, we don't know. Okay, right, means ಇದು ಯಾವಾಗ ಸಾಧ್ಯ ಹೇಳಿ? n greater than or equal to r ಅಂತ ಥಿಯರಂ ಪ್ರೂವ್ ಮಾಡಬೇಕಾದ್ರೆ, ಈ ರಿಸಲ್ಟ್ ಪ್ರೂವ್ ಆಗಬೇಕಾದ್ರೆ ಎರಡು ಸೆಟ್ ಇರುತ್ತೆ. we have two set of vectors, one set containing n number of vectors, the another set containing r number of vectors, whereas the set containing r number of vectors are linearly what? Independent. Okay, these are two important theorems we need to prove. We need all these results to prove, to work out a few more theorems. That's why I am recalling. Basis ಆಯ್ತು. ಏನಾಯ್ತು ಇವಾಗ ಸ್ಟಡಿ ಮಾಡಿದಲ್ಲಿ? we studied the definition of vector space. Fine. Then subspace ಗೊತ್ತಾಯ್ತು, linear combination meaning ಗೊತ್ತಾಯ್ತು, linearly independent ಗೊತ್ತಾಯ್ತು, linearly dependent, basis and dimension. Keeping all these ideas in mind, now I move to linear transformation. Linear transformation ಅಂದ್ರೆ ಏನು? Linear transformation means mapping. That means the correspondence. To define a linear transformation, we need a mapping from vector space U into a vector space V. ಅಂದ್ರೆ T from U to V. ಒಂದು ಮ್ಯಾಪಿಂಗ್ ಇದೆ, ನಮ್ಮ ಹತ್ರ ಒಂದು ಮ್ಯಾಪಿಂಗ್ ಇದೆ. ಸರಿ, ಎರಡು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು. ಎರಡು ಕಂಡೀಷನ್ ಯಾವುದು ಅಂದ್ರೆ ವೆಕ್ಟರ್ ಎಡಿಷನ್ ಪ್ರಾಪರ್ಟಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು, ಇನ್ನೊಂದು ದ ಸ್ಕೇಲಾರ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಫ್ ವೆಕ್ಟರ್ ಪ್ರಾಪರ್ಟಿ. ವೆಕ್ಟರ್ ಎಡಿಷನ್ ಪ್ರಾಪರ್ಟಿ ಅಂದ್ರೆ ಯಾವುದು? T of alpha plus beta, T of alpha plus beta is equal to T of alpha plus T of beta for all alpha beta belongs to domain of a transformation. ಯಾವುದು ಡೊಮೇನ್? U. ಯಾವಾಗಲೂ ಎಲಿಮೆಂಟ್ಸ್ ಡೊಮೇನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಇಮೇಜಸ್ ಕೋಡೊಮೇನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್, ವಾಟ್ ಐ ಸೆಡ್, ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ ಸ್ಕೇಲಾರ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಫ್ ವೆಕ್ಟರ್. T of C alpha. T of C alpha can be written as C dot T alpha, where C is a scalar and alpha is a vector. This we have studied in UG. We know the linear transformation. Again, using the linear transformation, ಯಾವ definition form ಮಾಡಬಹುದು? Range of a linear transformation. Next one ಯಾವುದು? Null space of a linear transformation. Fine. Again, using the range space of a linear transformation, ಯಾವ definition form ಆಗುತ್ತೆ ಅಂದ್ರೆ ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ? Rank of a linear transformation. And next one, using null space of a linear transformation, ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ? Nullity. ಇವಾಗ ಒಂದೊಂದಾಗಿ ಡಿಫೈನ್ ಮಾಡೋಣ. ಯಾವುದು? ಫಸ್ಟ್ ರೇಂಜ್ ಸ್ಪೇಸ್ ಆಫ್ ಎ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್. ರೇಂಜ್ ಸ್ಪೇಸ್ ಆಫ್ ಎ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಒನ್ಸ್ ಅಗೇನ್ ವಿ ನೀಡ್ ಎ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಟಿ ಫ್ರಮ್ ಯು ಟು ವಿ satisfying linearity property. Linearity property ಅಂದ್ರೆ ಯಾವುದು? Vector addition condition. The second one is scalar multiplication of vector. That is T of alpha plus beta is equal to T of alpha plus T of beta. The second one is what? T of C alpha is equal to what? C dot T of alpha. ಅಂದ್ರೆ range space of a linear transformation define ಮಾಡಬೇಕಾದ್ರೆ we should have what? A linear transformation. Fine. Next ಯಾವುದು? Range space of a linear transformation is denoted by the notation R of T or RT. It is a set. ಒಂದು ಸೆಟ್. ಸೆಟ್ ಅಲ್ಲಿ ಯಾವ ಟೈಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ? ಒಂದ್ ವೇಳೆ ಅಲ್ಫಾ ಡೊಮೇನ್ ಅಲ್ಲಿ ಇದ್ರೆ, ಇಫ್ ಅಲ್ಫಾ ಬಿಲಾಂಗ್ಸ್ ಟು ಯು, then its image, that is T of alpha, and I will denote it by beta, belongs to codomain, that is V. This is what? Null space of, sorry, this is called as range space of a linear transformation. Andre range space of a linear transformation alli only image elements ಮಾತ್ರ ಇರುತ್ತೆ. Now using the definition of range of a linear transformation, I can form the definition of what? Rank. Rank means the dimension of RT. The dimension of null range space of T is called as rank. Next definition, null space of a linear transformation. Null space of a linear transformation define ಮಾಡಬೇಕಾದ್ರೆ once again we need a linear transformation. Fine. Again, it is a set containing what? Zero vector. That means ಒಂದ್ ವೇಳೆ alpha U ಅಲ್ಲಿ ಇದ್ರೆ, that means if alpha belongs to domain of a linear transformation, then its image, that is T of alpha, is equal to zero vector, is equal to zero vector. It belongs to codomain, that is V. And again, the dimension of null space of a linear transformation is called as what? Nullity. And we proved one important theorem. Rank plus nullity is equal to the dimension of what? Domain, that is V. And all these definitions and the results related to what? The linear transformation were studied in UG. Keeping all these basic ideas in mind, I'll take the real syllabus, I mean the actual syllabus that we have to study in this semester, that I will take in next hour. Thank you. Have a nice day.